Okay, in this section 7-2, we are looking at similar triangles. Now, just like we had theorems that we could use to show that triangles are congruent, we also have theorems that we can use to show that two triangles are similar. Remember, similar means same shape, same shape. They can be various sizes, but still be the same shape. So the first triangle similarity theorem is angle-angle similarity, and it says that the two triangles are similar when two angles of the triangles are congruent. So like in this case, where I have one mark here, 2 marks here, 2 marks here. So like, for example, if this one is 45, 45, and this one is 60 and 60, then if two of the angles match, that's enough to say that the triangles are similar. And here's why. Remember, if two of the angles in a triangle match, the third one automatically has to match because of the fact that the triangles add up to 180 degrees. So if these two are the same, the third one has to also be the same. And remember, if all three of the angles are the same, then the triangles are similar. All right, so the next one, it's a side-side-side similarity. The triangles are similar if the corresponding sides of the triangles are proportional. Okay, so remember, it's not congruent, it's proportional. So once again, we're checking our sides. So 15 matches with, I don't have any angles marked. How do I know what 15 matches with? Well, when you don't have any of the angles marked, if you've got all of your sides, then the biggest side matches the biggest side. The middle matches the middle, and the smallest matches the smallest. 15 is in the middle, so it will match with 5, which is in the middle. And like I say, it's very important that you get this right. It's not always left side to left side or bottom to bottom. It doesn't match like that all the time. Okay, so you got to make sure that you're matching the biggest to the biggest, and the middle to the middle, and the smallest to the smallest. So next we come to 12, and 12 is the smallest side, so it has to match with 4. And of course 18 is the biggest side, it has to match with 6. And when you divide these out, they are all 3, and then so that shows that the triangles are similar. So again, if the corresponding sides are proportional, when you make your matching fractions, if they're all equal, then we know that the triangles are similar. So that's side-side-side similarity. We've got another one. That's side-angle-side similarity. It occurs when two corresponding sides are proportional and the included angles of those triangles are congruent. Okay, so if two corresponding sides are proportional, in other words, like if I have 8 here, and of course it would match the bigger of the two, which is 32, and 5 matching with the smaller of the two, which is 20. All right. So when I look at that and divide that out, those would both reduce down to 1/4. So they are proportional. So the only other part is the angle in between them the same? 48 and 48, the answer is yes. So as long as these two sides are proportional and the included angle, the angle that's in between them, is also the same, then we know that the triangles are similar. All right? So here are the type of questions that we will be looking at from this section. The directions say, tell if the triangles are similar. Don't forget about your symbols here. If they're similar by angle-angle similarity, side-side-side similarity, side-angle-side similarity, or you can put that they're not similar. Okay, so let's take a look at the first one. So in the first one, we are given all 3 sides in each triangle. So the one I need to test is side-side-side. So it's either going to be side-side-side or it's going to be not similar. All right, so how do we tell? We need to write out our fractions. Start with 4. Okay, so what does 4 match? Well, 4 is the middle, so it should match the middle, which is 12. So 4 over 12 is the first fraction. 5, we've got 5 over 14. The biggest side matches the biggest side. And then, of course, that leaves me with 3 over 12. All right, so I need to look at these fractions. And that's not 12, by the way. That's a 10. Let me go ahead and change that. Okay. All right, so when I'm looking at these and reducing these down, this reduces down to 1/3. This one is already reduced to lowest terms, and so is this one. So they're all 3 different. They are not the same. So what that means is that these 3 triangles are not similar. Okay? So remember, to be similar by side similarity, all of these sides would have, or all of these fractions would have to be the same, and they're all different. Okay. What about the next one? Let's see what scenario we have. We've got two sides and an included angle on this one. So which one are we going to check? It's either angled side, or it's going to be not congruent. So let's take a look, or not similar, I should say. All right. So first of all, let's check the sides. So we'll go 8 over 6. 8 matches with 6, and 4 matches with 3. All right, so those two are the same. They both reduce down to 4/3, or 1.333. And now, the only thing we have to check now is the angle in the middle, and it is the same, 70 and 70. So these two are similar by side angle side similarity. So what do we know? We know that these two triangles are the same shape. All right? Okay, let's go with the next one now that we're looking at. So on this one, we have been given all of the angles. And so when we look at that, we need to kind of go through and take a look at what we've got here. And so on this one, let's just say that this angle we're missing, and let's say that this angle we're missing. Okay, let's say we didn't have that. Okay, because if you've got them all three, if they all three match, then you know it's angle-angle similarity. But suppose I had this with one of them missing. All right? And so when I look at this, I say, well, 60 matches, but 50 doesn't match 70, so it's not similar. Well, hold on a second. Remember, all three add up to 180. So if I've got two, I can find the missing one. So 50, 60, and 70 add up to 180. 50, 60, and 70 add up to 180, right? And over here, 60, 70, and 50 add up to 180. So actually now once you find the missing angle, you can say, okay, 50, 50, 60, 60, 70, 70. Not only do I have two angles, but I've got all three of them. So it's definitely angle-angle similarity. Okay? So there you go. These two triangles are similar. So in ones like this, if you've got one angle of the triangle missing, make sure you find the missing one so that you can double check to see if you indeed do have at least two that are matching. All right, what about this one now? Okay, so again, my pattern here I'm going to check is side, angle, side. Let's take a look at the sides. So we've got 18, the smaller of the two, matching with 28. Okay, and we've got 24 matching with 36. Like I say, make sure you get the matching right. Okay. And once again, how can you tell? By the size. Smaller one matches smaller one, bigger one matches bigger one. All right, so when you reduce these down, this first one reduces to 9 over 14, and the second one reduces to 2/3. And so since these are not the same, even though the angle between them is still the same, the included angle, the sides are not proportional, and therefore it is not similar. All right, so be careful with that. Make sure that you're checking those. If you're having trouble reducing the fractions, just put them in your calculator and get a decimal answer. The two decimal answers would be different. Like this one is 0.66666, and this one is not that. It would be something different. That would also lead you to be able to tell that they are not similar. All right? That's it.